with the mean of 170 and the standard deviation of 8. Okay, so we put a square here. Okay, now, if the question wants us to find the percentage, okay, probability of H between 162 and 170. So if we use our GC to do, can you tell me what to do? Okay, Wing Shen.
Hey.
Can you tell me how to use my GC to get the probability for this one?
I don't think I know.
Hmm?
I don't know.
You cannot say you don't know. If you missed yesterday class, I got upload the thing, correct?
Yeah, I was gonna watch it at 4 later.
You cannot don't watch because today we are going to continue with that. Whoever missed the class, if you didn't watch, that is. Do you know the consequence of missing the class?
Yes.
So you didn't even take an effort to watch the thing, then too bad. Okay. Clarissa, can you tell me how to get the answer from your GC?
Using second verse 3.
Yeah. Second verse 3, what is that?
Inverse norm.
Why you use inverse norm? You want to find probability.
Oh, sorry, it's 2.
2, yes. 2, which is normal CDF, correct?
Yeah.
Yeah, so you put in normal CDF. Okay, lower boundary, upper limit, mean, standard deviation. Yeah. So remember, normal CDF is for us to find the probability. So what is the probability for this one? 0. Emily, what is the answer? Emily, what is the answer?
Oh, wait, miss.
How can? Just now, the moment I say the thing already, you have to quickly type in already. You have to be proactive. Yes, Emily, what is the answer?
0.3413.
Yeah, 3413. Yep. Okay, so if we approximate, we'll put 0.341. Okay, why we don't know? The reason is because if you look at page 234, 234 is a general true facts about any normal distribution. If it's between one standard deviation away, you see, our standard deviation is 170. Our mean is 170. So if I take 170 minus 8, I got 162, correct? So this area is 34.1%. So if you have that, you can also make use of it. You don't have to use your normal CDF. You see? Okay, so that particular information in your textbook in page 2, 3, 4 is for those who don't have a scientific, don't have a graphic calculator. So they also don't have the table. So they can use this to roughly know what is the probability. And this question asks us to put in percentage, correct? So we have to put as 34.1%. Yeah. And for part B, probability of H between 170 and 186. Okay. So you see, it's 2 standard deviation away. So you see 170 plus 2 times 8. So I got 186. So this area is 34.1 and this area is 13.59. So the value for this, you can try to use your normal CDF and get the answer. This question they give you just nice, huh? Can you get normal CDF and get the answer? Wait.
Is 0.4772.
0.4772. So 34.1 plus 13.59. You add. So 47.69%, correct? So you get your normal CDF, you also get that. Yeah. Do you get that?
Yes.
So we have a graphic calculator, so we can just get the answer. Yeah. So we have normal CDF, lower, upper, mean, and standard
Yes, I
deviation.
think you added it up wrongly. It's 34.13. It's 34.13, not 34.
I didn't put the 3, correct?
Yeah.
1, 3, eh? Okay, so we make it more accurate. So it'll be 472. So we get it from our graphic calculator. We were 477249. So it's approximately 47.7%. Pretty significant figure. Okay, for part B and part C, I let you do it by yourself. Okay, B and C. So from the group of 500, so you find the probability times 500, you will get the answer. Are you okay? So we shall do part D. Okay, they say estimate the value of K such that 16% of the students are taller than K. So that means now, if I draw my bell shape, this is my 170. Probability of H greater than K is 0.16%. So can someone tell me K is greater than 170 or less than 170? Jared?
K is
Greater or less?
It is lesser.
Lesser than. Okay.
Yeah.
If you say K is lesser than 170, okay, let me show it to you. K is lesser than 170. That means K is here. I want greater. So I have to shade the area to the right. My question is, can this area be 0.16? Jared?
Oh wait, no, it can't. Sorry, miss. It's smaller.
Yeah.
Yeah, it's
So
wrong.
that's why we have to know. Okay, that's why we have to know that this is the area. And how I know is to the right? Because greater. So 0.16 is the area to the right of K. 0.16 is less than 0.5. So therefore, K must be greater than 170. You see how I analyze? Do you get me? So this is wrong. Okay, so now I'm going to find the value of K. H greater than a value. And the probability is 0.16. So if I want to find the K value, the value of the height here, what must I use from my graphic calculator? Rush?
Hello.
Rush? Yes, what must I use?
In I and V norm.
Yeah, inverse norm. Yeah, you are right. Inverse norm. Okay, so what must I put in? 0.16, the area, the mean, the standard deviation, and this is area to the right of K, correct? So I have to put right here. If you are using this calculator, if you are using another calculator, is there anyone without this, your calculator? Hello? Ramisa, is your calculator with the word right, left, and center? Ramisa, are you there? Yes, why can't you talk? Is your calculator with this one? Ramisa? Okay, so you have no problem. Okay, now, how about anyone without? Whereby your last row, there is no right, left, and center.
So mine doesn't have right left.
So what to do?
Put the left one, 0.84.
Yeah, put the left. Thank you. Yes, 1 minus 0.16, correct? This area must be always area to the left of K, am I right? If you are having this kind of calculator. Okay, so what is the answer? Kelvin?
Yeah, 177.955.
177.
0.9556663.
955. So
Yeah.
approximately 178. Okay? Can or not? So you have to get it right. Normal CDF is to find the probability. Inverse norm is to find the value of the variable. See or not? Are you okay? Hello?
Yes, Miss.
Yep.
Okay, good. Can I? So you get that two right. Okay, now we are going to solve question 9. Can you please have a look at question 9 in page 236? You just read the question first. Okay. I purposely draw this. The reason is because the question said the weight of Jason orange is normally distributed. So the weight is normally distributed. I don't know the mean. I don't know the standard deviation. Yeah. Okay, but I know that the probability that the X is more than 152 grams is equal to 84%. Okay, now you add up the area until where is 84%.
%16.
Yeah. Okay. So what we know is half of the bell is 0.5, correct? So if I add another 34%, isn't it in total here? I got 84%. Hello?
Yeah.
So that means, can I say this is equal to 152? Can I say that?
Yeah.
So I can say that mean minus standard deviation is equal to 152. So I got one equation from that information. So now second information say that the probability of the weight, that is the X, greater than 200 grams is equal to 16%. Now, if you look at here, if I add from here to here, do I get 16%? 13.59. Or easier way is what? What is the easier way? I take 0.5. I take 50%. Take away 34%, correct? So do I get 16%?
Yeah.
So can I say that mean plus 1 standard deviation, this is my X value equal to 200 grams? Can I say that?
Yep.
So can I find the mean and the standard deviation now?
Yes.
If I add up these two, I will get 2 mean equal to 352. So therefore, the mean is equal to 176 cm. And the standard deviation will be equal to 200 minus 176, which is 24 cm, 24 gram. Okay, usually like fruits, this kind of thing, they will have very high standard deviation. But if for talking about machine field thing, right, the standard deviation should be low. Am I right? Okay, are you done?
Mm-hmm.
So that is how we use this. Okay, so today I'm going to continue the lesson with, can I move?
Yep.
So the rest you can do. Oh, okay, one more question to discuss before I go to the next one. Okay, can you please go to page 239? Okay, let's do question 10. This is a very important question. Example, I expect you to go and read by yourself. You see the example there? They say self-tutor. That means you can study by yourself. People found to have high blood pressure, they always will tell you a lot of things, prescribe a tablet. So after they take the tablet, at the end of the 4 weeks, there's a drop in blood pressure over a period is normally distributed. So what is the variable X? Okay, your X is the amount, or I can say unit of blood pressure drop. Unit drop of blood pressure. Can or not? Okay, unit drop of blood pressure. Okay, and the question said that X is normally distributed with a mean of drop of 5.9 unit and a standard deviation of 1.9 unit. Okay, so I want to find the probability that percentage of people who show a drop of more than 4 units. Okay, so which one must I use? Since X is normally distributed. Wing Xuan.
You mean like
You
which
should know now.
function to use?
Which function to use to get the probability if X is normally distributed?
We can use normal CDF, right?
Yes, you can use normal CDF. Okay, so it's 4 unit onward. So this will be the lower limit. Okay. Hydrate. What is the upper limit that I must key in? Hydrate. What is the upper limit that I must key in?
10 to the power of 99.
Thank you. 10 to the power of 99. That means you just put it very big. Then the mean and the standard deviation. Okay, what is your answer? Mikia, can I have the answer? Mikia, can I have the answer?
Okay.
You
Or
see, you can't give me the answer. means
4.1.
Faster, faster. Give me, don't quarrel. Don't quarrel.
4.1%.
Huh? Excuse me?
Yes.
Can you repeat again?
34.1%.
4.1%. This one. Sure.
Yeah.
Is that correct?
No.
No.
This is 84.1%.
84. Not 34, is it?
Yeah, it's 84.
Yeah.
84.1%. Mikia, you sure you get 84 or 34? Mikia, can you please answer me?
Yes.
You get 34 or 84?
84.
84 or 34? I tell you, this test, if you don't know how to use your graphic calculator. Okay, so that means if I put as proportion, it will be, yeah, 84. Okay, now you tell me for part B, 8 people taking the course of tablet are selected at random. Find the probability that at least 6 of them will show a drop in pressure of more than 4 units. So whatever in part A that you can see in part B, which part of it? Do you see that this is in part A? This is from part A, correct? Show a drop in blood pressure of more than 4 units. So you see this is from part A. So do you know the probability for this to happen? What is the probability for this to happen?
84.1%.
Okay, 0.84, correct? So you think that part B is a normal distribution or a binomial distribution? You have 8 people. This is a group of 8 people. So I ask you, for part B, is it a binomial or a normal distribution?
Binomial.
Yes, binomial. So I have to use another new variable. I call it y. Y is what? Number of people show drop of blood pressure of more than 4 units out of 8 people, right? So Y is a binomial distribution. What is the number of trial?
8.
Yibin?
Yes.
What
8.
is the number of trial? 8. Marcus? what is the probability of success? That means a person has a drop of BP more than 4 units. Marcus, what is the probability of success?
0.841.
Yes, 0.841. So what is required by the question? Phoebe? You want to find the probability of what? Y? Yeah, Phoebe, Y? Greater or smaller? Find the probability of at least. At least means greater or equal to 6. So how are we going to do this? How are we going to do this? Calculate this. Renat? How to calculate this?
Binom CDF.
Binom CDF. Okay, you tell me how to use binom CDF. Okay, you want to use binom CDF, so what to put in? The N is 8. The probability of success is 0.841. Then, what is the R that you want to put in?
6.
6. Okay. Renat, let Miss Do explain to use this. If I use binom CDF, it means that Y equal to 0 plus probability of Y equal to 1 plus until probability of Y equal to 6. Is that what I want here? Renat, you have to continue to answer my question while others are thinking. Is that what I want here?
Oh no.
No. Okay, so Renat, tell me what should I do? So always remember, binom CDF means from 0 to whatever number you fill in here. So Renat, how to do?
So it's binom PDF.
Okay, if I say binom PDF, do you know I have to do how many times? I have to do it 3 times. Am I right? Because I want 6, 7, and 8. Okay, Renat, can I put 9? Can I put 9 here? Or should be Y, not X, Should be Y. Can I put 9 there?
Cannot. Because
Why not?
The amount of trials are 8 only.
Correct, you are right. You see? So it's good for a teacher to ask nonsense question. So this one cannot, because N is equal to 8. So highest you go will be 8. So you have to use binom PDF 3 times. So if I got 10, then I have to repeat 10 times. So is there any other better way of doing it?
Do we do 1 minus binom CDF?
Why not? Because probability for the whole scenario to happen is 1. So 1 minus binom CDF. Put in and 0.841. Okay, what number must I put in here? 6 or 5? Wenjie?
6.
6
Oh,
hey,
5.
saya mau
5.
6 deh.
5.
5. Yes, you are right.
Yes.
Okay, then you use your calculator and count. You only use one. So you can use the top or the bottom, your choice. So this coming test is how sure are you what to use and how to use it? Okay. Now, done? Hello?
Yes, miss.
Okay, okay, so have to have very clear cut. When to use binom CDF, when to use binom PDF, when to use normal CDF, when to use inverse norm. Okay? Now, yeah. So now, this one I'm going to discuss is something to do with your ETA score. You know how your ETA score come about? How your scale score come about? Okay, let's look at a class. E is the result for EAL, okay? Yeah, your EAL, English. Okay, for a group of students, it is normally distributed with a mark of 75 and a standard deviation of 9 squared. A standard deviation, okay. M is for math method, okay, MM. So it's normally distributed with a mean of 52 and a standard deviation of 12. So I have this student, his name called Ali. Ali EAL mark is 70. And Ali math mark is 60. So now, based on Ali's mark, Ali performed better in EAL or maths.
On marks alone, it would be EAL.
Yeah, on mark alone is EAL, correct? 70 mark.
Yeah.
Then your parent will start to score. The Ali parent, why you can score 70 in EAL and yet you only score 60 in maths? So how a maths teacher going to justify?
That you show the parents like the average marker and say it shows that Ali is above average when it comes to maths. Because maybe the difficulty of the paper is just very high, you know.
So Ali performed based on this only. Ali performed better in maths or in EAL?
Wait, can you repeat that?
Definitely, because it's above average based on this mark. Correct? So I have to know the average. Yeah. But in EAL, Ali performed below the average. So how can you say Ali performed better in EAL than in maths? So the maths teacher will justify like that. So now, never mind. Now we change Ali math mark, okay, to 51. So now you think Ali performed better in maths or in EAL? You cannot take already above average or below average. Both are below average. So how are we going to get the scale score? Okay, so now I'm going to draw. So this is EAL. The mean is 75. Okay. And this is math. The mean is 52. Okay, what is Z? Z, we call it a standard score. Or we call it standard normal distribution. If I say that is a standard normal distribution, means the mean is 0 and the standard deviation is 1 unit. Are you clear? So now we are going to standardize everything. Okay? So if you get 52 marks in maths, your standard score will be 0. If you get 75 marks in EAL, your standard score will be 0 also. So if you get 1 standard deviation away, 52 plus 12, 64, then your standard score will be 1 for math. But if for EAL, you got 84, then your standard score will be 1. Clear? Okay, now, if you get less than that, 75 minus 9, what is the answer?
66.
66. If you get 66 marks in EAL, then your standard score will be -1. If you get 52 minus 12, 40 marks in maths, so your standard score will be -1. Okay, now, based on this, it can go on. So now you look, 50 is here. So the standard score will be around here, am I right? Okay, 70, here is 75. So it will be at the middle, around that. So whose standard score is lower? The standard score of which subject is lower?
English.
English. Z of EAL for Ali is less than Z score for math for Ali. So Ali performed better in math or EAL?
Math.
Math. So how to transfer a X score to a Z score? So you go by this formula. You see how 75 becomes 0? You minus the mean, am I right? So the formula will be the X score minus the mean divide by. What do you think? You should divide by. Ask yourself, how
The standard
84
deviation.
become? Yes. So this is an important formula that you have to remember. So what is Ali's Z score if go by that formula for EAL? Okay, Ali mark is 70. Yeah, so here is 70. So 70 minus 75 divided by 9. Okay, can you take out your calculator and calculate?
Negative 0.55556.
Okay, so it's negative 0.556. Okay, how about the Z score for math? It's 51, right? So 51 minus 52 divided by
12.
12. 51 minus 52 divided by 12. So this is only negative 0.0833. So therefore, so when you talk about your scale score, right? So Ali will have a higher max scale score than who?
Then
max scale score than the EAL scale score. So your ATA scale score is go in that way. Yeah. Hello.
Mm-hmm.
Yeah.
From my past experience, Max usually got a higher scale score. Yep.
Mm-hmm.
You got an A, you may not be getting the same scale score. Okay, are you okay now? So now, with the knowledge I have, if I don't have the standard score idea, okay, so any score can transform into standard score, remember, by using this formula. Okay, if I don't have this knowledge, can I solve this question with another method? Can I solve this problem with another method? Can I count the probability of a student who perform better than Ali?
Yeah.
Can you please try?
Hold on.
Do you think perform better than Ali? So if I say probability better than Ali,
Wait, that means their standard deviation score for both maths and English must be
No.
higher.
They are different. So EAL perform better than Ali means I want to find the probability that the English mark is more than Ali. Okay, so I want to see the percentage. For math, better than Ali means their math mark must be better than Ali. Okay, so what do you use? You use normal
CDF?
Yeah, you use normal CDF, quick.
Okay.
Junjie, I want the answer for EAL. Stephanie, I want the answer for Max. Sorry. Okay. I got call from Taylor office. Okay. Can just now I asked who to give me? Junjie. Answer for this one?
Wait, I'm still calculating.
Still calculating, Junjie. Answer for this one? Quick. If Mr. get the answer, you haven't get the answer then. Normal CDF, lower 70, highest 10 to the power 99, mean 75, standard deviation 9. Junjie?
1.1%.
0.711.
71.
711.
Yeah, 711.
So that means 71.1% perform better than Ali.
Mm.
Okay. Stephanie, the next one.
Hi, Miss. I got 0.533206.
0.5.
Yeah,
5,
332.
3, 3. Okay, possible. So that means 53.3% perform better than Ali. In math. Okay, so that means the percentage of students who perform better than Ali in EAL is higher than in maths. Therefore, Ali perform better in maths or in EAL. So you can use different method. So you get me? Okay, so what is the purpose of standard score? So that we can make a very quick comparison if we don't have a graphic calculator. You can compare between the rest. Okay, later I will teach you what is another use of standard score. Can I not? Hello, student?
Yes.
Yes.
So do you think it's fair or not? We have standardized score.
Yes. Very fair.
Very fair. If you don't have a standardized score, then it's very unfair, correct? Maths is a much tougher subject compared to others, am I right? Are you? Do you think so? No.
Maybe some sciences can beat maths.
Yes. No. But do you know now if you want to be good in other science subjects, right? Actually, you should learn how you think in doing maths. Because when we talk about maths, right, you see, we have a lot of options. I can use graph to compare. I can use to calculate the exact standard score, or I can use probability. So maths actually give you room to solve problem in a different way. So depend on what you have, what resources you have, you solve the problem. That's why maths is a very practical subject. When you want to solve a problem, you not only look at the problem, you look at what you have and what must you do. Hello? Okay. So I will see you tomorrow to discuss further. Can?
Yes, Miss.
Yep.
Class?
Yes.
All right. Thank you, Miss.
Thank you, Miss.
Thank you.